We think we know what fast is, right? A sports car, a fighter jet. But what if I told you there's a speed limit for the entire universe? An absolute, unbreakable law of physics. Well, today, we're going to buckle up and take a ride at that exact speed. Okay, get this. In the few seconds it took me to say that, light just wrapped around the entire Earth 7.5 times. Yeah, mind-blowing, right? So that kind of speed is it's almost silly to think about it just here on Earth. So let's do something bigger. Let's take that speed and go for a joyride through space. What happens then? Right, this is it, the ultimate speed limit. So what are we talking about? Exactly. We're talking about the speed of light. It clocks in at an insane 300,000 kilometers every single second. But here's the cool part. For scientists, it's not just about being fast. It's their ruler, their cosmic yardstick for measuring the just absolutely insane distances out there in space. All right, you ready? Let's hop in our light-speed ship. We're taking off from Earth right now. First up, a little tour of our solar system. Okay, first stop, the moon. Boom, 1.25 seconds. Done. Want to go to Mars? That'll be about 3 minutes. The sun? A little bit longer, about an 8-minute trip. We're cruising now. Jupiter is 33 minutes away. And to get all the way out to Saturn, to see those incredible rings, we're talking 67 minutes. An hour at the fastest speed the universe allows. You know that 8-minute trip from the sun? It has a really weird side effect. Think about this. If the sun just, poof, vanished right now, we wouldn't have a clue. For 8 whole minutes, everything here on Earth would seem perfectly normal. The sky would be bright, we'd be going about our day, totally unaware that our star is already gone. So a little over an hour to get to Saturn. That sounds pretty darn fast, doesn't it? But this is where things get really interesting. How does that cosmic speed limit stack up against what we can actually do with our own technology? Yeah, I love this quote. The vastness of the universe makes even light seem slow. I mean, let that sink in. If light itself seems slow out there, what chance do our little spaceships have? Okay, so we've established the benchmark. Light takes 67 minutes to reach Saturn. Now for the big question. How long do you think it takes our fastest probes to make that same trip? I mean, really, take a second. What's your guess? All right, brace yourself for a reality check. Let's look at the actual numbers. Pioneer 11, 6.5 years. The Incredible Voyager probes, 3 to 4 years. And Cassini, the one that gave us all those jaw-dropping photos of Saturn's rings, almost 7 years. 7. Even our Speed Demon, the New Horizons probe, took 2 years and 4 months, and it wasn't even stopping. It was just doing a flyby on its way to Pluto. So let's just put that side by side. 67 minutes versus 2 years and 4 months. That's not just a gap, that's a chasm. It's an absolutely humbling perspective on just how impossibly, mind-bogglingly big our cosmic neighborhood really is. But you know us humans, we love a good challenge. So if getting to a giant planet is that hard, what about something even trickier? Let's talk about a mission to a tiny, hard-to-reach target called a Trojan asteroid. Okay, so what in the world is a Saturn Trojan? The best way to think about it is like a little cosmic sidekick. It's a small asteroid that's been perfectly trapped by gravity, so it shares the exact same orbit as Saturn, just hanging out ahead of or behind it. And get this, we've only ever found one of them. Its name is 2019 UO14. And this thing is super weird. It's not just some boring space rock. Scientists think it's an object from way, way out in the Kuiper Belt. It might even be active, kind of like a comet, venting gas and dust. Plus, its orbit is tilted at this crazy 30-degree angle compared to everything else. All this makes it a super exciting scientific target. But also, you guessed it, an unbelievably hard one to get to. So, how on earth do you even begin to plan a mission to get there? To this one tiny, weirdly orbiting rock so far away? Well, you do it with what is basically the most complex game of interplanetary pool you can possibly imagine. Check this out. The plan is to launch in 2035. Then you swing by Mars to pick up some speed. Then you loop all the way back to Earth, twice, for 2 more gravity slingshots. And then for the grand finale, you use the massive gravity of Jupiter to fling the spacecraft out on its final course. It's this incredible, intricate dance across the entire solar system just to meet up with this one little asteroid. And the total travel time for this grand tour, 13.4 years. Think about that. over 13 years of just coasting through space to get there. And that just leaves you with this kind of awe-inspiring and honestly humbling thought. If it takes us over a decade just to reach a special rock in our own solar system, what does that mean for our dreams of ever reaching other stars? It really puts it all in perspective, doesn't it? The universe's ultimate speed limit isn't just a number. It defines who we are, explorers, standing on the edge of a cosmic ocean that is vaster than we can possibly imagine.